We actually went from a toy excavator in our apartment in a literal sandbox to like putting it on an actual excavator in the demo day, showing it to them that you have the understanding of the industry, and you understand their problem and you're making a solution to solve those problems.
If I tell you YC startup, you're thinking, oh, it's got to be a AI SaaS tool, a B2B tool. Well, not today. Today we have an entrepreneur who's building a company that's actually moving Earth. You can do more hardware than that. So I'm very happy today to be with the founder of Flywheel AI, Jash, from the very latest YC batch. YC is helping build hardware companies. So Jash, welcome to the show.
Hey, Gabriel, nice to see you.
Good to have you here. So Flywheel is building Waymo for excavators.
That's right.
That's crazy. Tell us more.
Yeah, so essentially what we are doing is we are enabling existing excavators in construction for the contractors so it can be remotely teleoperated, and we are making it autonomous. So that's the reason we call it Waymo for excavators. Yeah. And if you're in San Francisco, you see a lot of Waymos driving around without any person sitting inside. And there is no upper cap on how much Waymos could be useful or the amount of rides you could take. And we are taking that upper cap, all the bottleneck essentially in construction, which is usually human capital away.
That's awesome. Okay. And yeah, I mean, you're right now, I'm guessing what the audience is thinking. What I thought the first time is it's probably more difficult to operate a Waymo autonomously with people crossing the street, and especially here in San Francisco, some people just cross in the middle of everywhere,
That's right?
Then a simple, and of course it's not that simple, excavator
Right.
just picking up dirt. There is also a very big labor shortage, right?
Mm-hmm. Yes, that's true. The labor shortage exists in any developed country. So any developed country, high GDP per capita countries that you go to, it's usually very hard to find those skilled operators. Nobody wants to do these jobs anymore, especially like Gen Z won't do these jobs anymore. There are many different avenues to make money now. And what we are seeing is the median age of the construction workers that we have now is increasing. It's about 45. There's not new people joining in. And so before we know, the available workforce is going to shrink a lot. And we have a lot more construction going on. It's an interesting time in history where all the developed countries, again, are like infrastructure starved. We have to make data centers, we have to make new projects for highways, trains, and we just don't have enough people.
It's crazy. You cannot make a new data center today
Yeah,
without a single excavator.
Yeah.
No one thinks about this.
exactly.
But every single data center in the world,
Yes.
anywhere, not just in the US,
Yeah.
at some point there has to be an excavator.
Oh, yeah.
And
At every point in the timeline, they need to have an excavator.
Always. It's
Yeah.
crazy. Like no one
Yeah.
presented it this way before.
Right.
And there's a labor shortage. We can't operate them.
Yeah.
And it's interesting. People have been talking about how AI is bringing those new needs of welders and different kinds of manual work.
Yeah.
But no one talks about the excavator.
Yeah.
And it's a like, if you don't even have a building, if you don't have a hole in the ground, you can't
Yeah.
do anything. That's crazy. I love that. It's also dangerous
It is.
to operators. Can you talk about that?
Yeah. Also on the previous point, like, people could do a thought experiment when they're driving back home. They could just count the amount of excavators. Like usually it's in the, you don't really notice the excavators, but when you actually start seeing it, you just will be blown away by how many are there even in your, commute. Excavators are pretty dangerous. So like these are literally machines that you use for moving the earth.
Yeah.
And so you can move like 5 to 6 tons of earth at once with one scoop of bucket.
5 or 6 tons?
Yeah.
Wow.
It could be even more.
Wow.
And so imagine that much of power, and you can easily just flick apart, you can essentially kill a person just by swinging. And there's a lot of blind spots in the excavators as well. And so all of that combined, it makes it very dangerous. So what I mean by that is when you have blind spots for the operators who are sitting inside the excavator and operating, the way construction solves that is by employing a few people to stand around, essentially as third camera view. And they would then verbally...
Just people?
Yeah, just people standing there very close to the excavator because, you do not have visuals on the blind spots. And they would verbally instruct the operator sitting inside on how they should be moving. which is crazy. Like,
It is crazy.
yeah,
It's crazy.
exactly. For like two reasons. One is it's pretty suboptimal. Like, imagine having to like close your eyes and just rely on your friend on their verbal instructions on how they should be moving.
Yeah.
I mean, you're gonna bump into the walls.
With a potentially killing machine.
Exactly. Yeah.
That's
So,
crazy.
yeah.
I cannot even believe. I didn't know that. It's so, I don't know, antiquated. In 2025,
Yeah.
you have just people. Okay, anyway, there's a second reason you said. A second reason why they stand around.
Yeah, no, so like when they stand very close to the excavator, it's just so easy for them to be in the way of the excavator. And so like when you swing, because they have to stand so close to eliminate the blind spots, they are essentially like, very highly probable to be hit by it. And that's usually what happens.
So the people that get hurt are the people that are so close.
Exactly.
Wow, okay.
And so most of the deaths in construction that usually happens is, people get trapped in the tracks of the excavators, or when the excavators swing, somebody gets hit by the excavator because they don't really see when they're swinging. Even with remote teleoperation, once you have 360 vision, you don't need to hire those people, and the operator just has much better visuals. It's like, if you play games, it's the difference between playing a FPV game versus like third person view, where you can see the vehicle and everything around it.
Yeah.
It just, you can just move it.
So
much
you go
better.
from first person view in the excavator to third person view.
Exactly,
and you can
yeah.
see around. So that's just tele-op. So many things to talk about here and to discuss. But basically, those people are sort of necessary today.
Yeah.
And you would think maybe the new generations of excavators, the next ones, because if you think of the cabin, yes, it's very rigid, has lots of things, so that's why you don't see really well.
Yeah.
They could maybe build a cabin with lots of glass, maybe, and mirrors and whatever. But that's for the next excavators. But there's millions of excavators already here on the market.
Yeah.
So your solution is a retrofit.
Yes.
That's one thing. We're just unpacking how much of this makes sense. I mean, I believe it does. Let's, by the way, if something doesn't make sense, tell us in the comments and we can, do a second episode or whatever. Or you can just answer on Twitter and yeah. But you go from first person view to third person view. And so you're retrofitting existing with tele-op plus cameras.
Right.
And then you have is it a single screen, I believe, or a few screens that sees 360 degree around you, right?
That's right.
Yeah.
So we could do multiple screens, but we are doing a lot of work in the visual element of it to make sure that we can just use one screen. And then we do a lot of work in remote teleop so that you don't have to move around to different screens. And so like the operator can just look at the main screen. If you think about it, the human vision is 120 degrees with like binocular vision, and the single like point of interest vision is about 60 degrees. So it actually makes sense to put everything on one screen and just move around those video frames based on how you're moving.
Exactly. Like if you're moving left, you don't need to see the camera on the right.
Exactly.
Because there's no danger. You need to be moving left. Okay.
And you might have seen a bit of that, when you tried it on the demo day.
I did try it. So yeah, it was, many people hopefully saw it in the media, on social media. You can go onto my account for sure. I tweeted a few of those pictures and videos of, it was a demo.
Yes.
Physical one at demo day. So we'll get back to this in a second, but
sure.
What's also very interesting as well is then, again, let's forget about autonomy for a minute. We'll also come back to that. But even when it's teleop, then you just need one person instead of the one driver plus the people around. So it goes from 3-4 person to operator to just one.
Yeah.
And then they can be inside.
Yeah.
When it's super hot, when it's raining, when it's whatever, you could be in an AC room.
Exactly.
And could you be in another country as well?
You could be in another country. We haven't done that yet, but the tech works and you can be literally in a different country. So imagine like most of the highway works happens at night. You could have operators in a different country where they are working in the daytime and they're operating the machines here. And so there's a lot of that kind of advantage which comes with it as well.
Just ripe for disruption, this space. It's crazy. It makes me think of those army drones that are,
that's so good
piloted by soldiers on the ground.
Exactly.
And there's so many advantages, especially it's less dangerous for them as well in combat zone. And it's here, obviously we're not talking about combat zone but it's also a danger of death.
It is.
And by the way, I think I remember, it's also very costly when sadly an accident happens. Obviously it's bad for the person that's injured or killed. That does happen. That's obviously the worst part. But also it actually takes, like, they have to stop the entire job. It takes time. They pay penalties and fines and insurance, and so even financially, obviously
Yeah.
the worst part is the people injured, but
Yeah.
even financially, it makes sense for them to go this route, doesn't
Exactly. Yeah. So whenever a safety incident happens, which means that accident which leads to injuries or deaths, you have to pay hundreds of thousands of dollars in penalties to OSHA or an equivalent organization. Your site gets shut down by OSHA while it's being investigated for a few weeks, and those delays leads to added costs because most of the contractors work on external financing. And the way construction works is you have multiple different contractors and subcontractors working on the same site, and you don't want to be a hard company to work with. So if you're introducing delays, those delays are going to cascade to other companies, and even when it happens once, it essentially affects your prospects for getting new projects. But if it happens a few times in a row, the penalties can go in millions. Your site can shut down for few years, or even a decade. At this point, about 150 billion or more is paid to OSHA every year in penalties.
Wow.
And on average, a construction company pays about 300 or 400K in penalties. So it's literally the most important thing for construction companies to make sure that doesn't happen. And then obviously, it's bad PR because you don't want to read about your company in the news in that context.
Yeah, for sure. Okay. Wow. Insane. So I'm trying to remember everything we have to go through because there's so many very cool things. So today it's tele-op. It's retrofitted, right? You should
Yes.
probably say that. It retrofits any existing excavator.
Yeah,
Let's talk about autonomy.
sure.
That's the, I was going to say it's the interesting part. I mean, the rest is super interesting as well. But yeah, let's talk about autonomy. Where are you? What's the goal there? When do you get there exactly? I know it's in different steps.
Yeah.
It's not fully autonomous, but somehow. So yeah, could you expand on that?
Yeah. So on a high level, you want to make all these equipment autonomous, and to solve the autonomy, you can either do a very case by case or very side by side basis autonomy, where you just do a lot of non-scalable settings for a particular site, which would make the operations very expensive for you, which is viable for something like mining, where you have the same site which is going to be operated for many decades.
Yeah.
But when it comes to construction, you shouldn't really do that. You could do that, and you could make you could make headlines, but then you're not really realizing the goal of having scalable autonomy. And why can't we do autonomy is we don't have the data sets to train autonomy on. We don't completely understand all the edge cases. And so if you think about Waymo or any self-driving company, for the past decade or even more, what they were doing is they were driving the cars around. They were collecting those edge cases. They were collecting those data sets of every city that they have deployed in to understand how the world looks like. And then they develop the policies for the autonomous navigation. We sort of are doing that, but we are doing that profitably. So the remote tele-op helps us to profitably collect those data sets and then train autonomy. And we want to do that with a very minimal hardware setup. And so if you scale up data collection, you could push out autonomy with a very minimal hardware stack, pretty much like a robotaxi where you just have camera-based systems. And when you do that, it's just no-brainer that you would have much better chances of retrofitting most of the excavators in the world. And you could argue that LiDAR cost is going down, hardware is getting cheaper, but it's a cascading cost addition and also makes it technically harder. So let's say instead of 6 cameras, which is what we do, use a few LiDAR and 3D sensors as well. Well, now to process all of that, you need much more powerful compute. Well, okay, that is getting cheaper as well. But now you need to train a much bigger model, which is much higher parameters and a larger model essentially, which is, let's say that's fine. But now you need to inference that model in low latency for it to generate the action, which is essentially the autonomy. And that is super hard. Even doing the models of the size that we are working with right now is pretty hard to do in low latency. And it's, it doesn't really, cameras is something which works in pretty much all the weather conditions and all the different sites. And that the benefit we have is we have deployments in Singapore and US, very different weather conditions. We understand like a lot of different extremes of how construction sites can be. And so that diversity in the data that we are collecting helps us to create a better model as well. And so it's just a very lean approach to keep the hardware minimal and just deliver on something so you get taken seriously as a construction company from day one, and not get stuck in pilot hell, but like you're delivering some value today, and then you essentially go do autonomy without having to change anything on those excavators. So that's essentially how I think of it.
It's amazing, and I think everyone here noticed how close it is to the Tesla playbook.
Yeah.
Everyone has been saying, I'm not teaching anything to the audience, that Tesla is probably the company that's one of the best positioned to win autonomy, because they've been collecting all those data sets.
Exactly.
Because they have the most cars on the road.
Exactly.
They have the most cameras on the road.
Yeah.
They have the most data. Like you said, it's all about the edge cases.
Yes.
It's very easy for Tesla or for you or for anyone to get to 98% autonomy.
Yeah.
That's very easy for almost anyone.
Exactly.
But going from 98% to 100% or 99.999,
exactly,
like that's very difficult. Again, everyone knows that. So the company that wins is the company that has the most data.
Yeah.
And just like you said, here in San Francisco, we see the Waymos driving around, but we see other brands driving around all the time with actual drivers.
Yeah.
And some of them, I think it's Zoox, they've been here more than 2 years.
Right.
And I was talking about it with a few friends. I was like, it's been 2 years and they're still here, but there's no actual cars on the road. That's how long it takes. That's how difficult it is. And so now it becomes, and maybe it's a good segue to talk about your competition. It becomes, how do you get the biggest data set? Without the data set, you just can't build autonomy. Your idea, which I think it makes a lot of sense, is we'll do tele-op, we'll put the cameras, we'll do the retrofit. This is how we gather the most data.
Yeah.
That's how we get to autonomy.
Yeah.
So I think that's really cool. So let's talk about other people trying to build this. There's other companies building in this very space. Here from Silicon Valley, funded. So that's it's a good thing. It means there's a real market here, but it's also maybe a bad thing because they're trying to do the same thing. So how do you think about that? How are you different? You probably have a way of thinking we're better. Hopefully you do. So let's go ahead. Tell us more.
Sure. So the way I think of this is, the way this is different from self-driving on public roads is, if you have your Waymos on the construction site, there cannot be any other company. So like if in a construction site, you have your excavators which are retrofitted, you're the only one who is collecting those data sets. So how do you do that? You do that with delivering something today which is of value, and you just scale that up quickly. And that's where the magic of the retrofit design that we have come up with comes in. So like, you might have seen that on the demo day. We are able to retrofit any existing excavator of any size
in a couple hours, right?
In just a few hours during the lunch break. So it's like minimally disruptive, and we have done everything from 2 tons to 40 tons for like different brands as well, like Kubota, Komatsu, Volvo, Hitachi. Most of the other brands only work with a few which have drive-by-wire system, which is sort of similar to how cars work, where they have electric signals which they can reverse engineer and send from their computers, which is only about at max 5% of the millions of excavators.
Oh, wow.
And so the solution is pretty limited in that sense.
That's for all of the other competitors?
All the competitors.
Wow. I'm sure there are some advantages probably in going with the electric signal, I guess.
The benefit is like it's much straightforward to do that retrofit.
Because it's just like a USB key.
Exactly, yes.
It's a program. Put into but it's 5%.
Yeah, it's at max 5%. Wow. And there is no real trend that those kind of equipment are increasing as the time goes by. And so, interestingly, even in US, the share of Komatsu excavators sold in the last few years increased compared to Caterpillar. And Komatsu, to give an idea, is completely hydraulic machines. And so it's very price driven. And so you essentially...
Yeah, I mean, on an excavator, you probably don't need the fancy one with the screen. And if it's moving dirt and it's cheap, construction is really price oriented.
Exactly, yeah.
If you can save 5-10K.
Yeah.
Like it makes a lot of sense.
Exactly.
Sorry, keep going. Yeah.
Yeah, like nobody thinks, that I need a cup holder in my cabin
Yeah.
and I'm gonna choose this model because of that. It's just it does the same amount of payload, which is cheaper. I'm just gonna get that.
For sure. Yeah.
And so your solution has to work on every machine that they have in their mixed fleet. It cannot just work on a particular segment of those machines. And you need to do it in a way which is not going to like void their warranty or like not going to make it harder for them, where the fallback would be worse than what they already have. And so you have thought a lot of that to make sure that the retrofit is actually something which is very productized in that sense. And
so it does not void the guarantee, right?
yeah, it doesn't void the warranty. It's pretty easy to install or uninstall. Even when it's installed, you can still manually operate it, and we still collect those data sets.
Yeah, you could even, if it goes back
Yes.
for a problem, you could remove it discreetly.
Exactly.
No one knows it happens.
Exactly.
Okay, I see what you're
And yeah, and we are already deployed. We actually open source the biggest data set in the community that we collected from actual excavators that we have retrofitted on real construction sites.
Wow.
And
Congrats.
yeah. And that is the first time that robotics researchers, have access to real world data set to train autonomy on and try different approaches. And there was a lot of sort of, so the other interesting thing which you have to do for autonomy is the physical form of it. So, humans evolved a lot in how we look today. We have to do that for the hardware configuration as well in terms of what are the camera views that we are collecting for autonomy. And we have just done a lot of those iterations to come up with the current hardware stack we have and the way we place the cameras and the retrofit.
I don't know, we were talking initially about competitors.
Right.
Is it different from them?
Yeah, it's different in the sense that we are not trying to do autonomy from day one. We are delivering something of value today which works on every existing machine. We honest works on not just excavators, on other equipment as well, but we are just focused on excavators. So it's a solution which is delivering value today, which is, reducing safety incidents. And then in the background, we are scaling up data collection and, we have put out some of it already.
Like you said, you don't get stuck in pilot hell.
Exactly.
You can implement today.
Exactly.
Potentially you could implement today on clients that don't even care about autonomy.
Yep.
They just care about retrofitting.
Exactly.
And so none of the other competitors are doing that?
Not really. So
obvious.
Yeah.
Okay, I love that. Okay, very cool. So let's talk about Demo Day briefly, and then we'll talk about your YC experience as well. But when did you think, so you had an actual excavator at Demo Day. When did you get this idea? What did YC say? Your partner, Enkit, or whoever is in charge of, you said, oh, guys, we want to bring in actual excavators. They must have thought you were crazy. What was tell us the story.
That was pretty interesting. So the idea came when we had this session with Paul Graham in the original YC office.
Wow.
And in the original YC office, they have the cruise car.
Oh.
That's the Audi car that Kyle used to show a better version of cruise control on his demo day.
Wow.
And
the car was there.
The car is there, and it has the retrofit that Kyle has made for the first version of cruise. And I and my co-founder, we just started thinking okay, what's the version of cruise that we could do?
Yeah.
And we just thought, let's just get an actual excavator, let people remotely teleoperate it, let's show autonomy, let's show all the parts of the, product that we have, which we can't just do with images or with a toy excavator. And we spoke with our partner and we sort of told what the idea is. It's a no-brainer that if you can actually see it out there, you just have much better idea, especially because it's hardware. And yeah, they were very supportive of it. And then next thing what we did was we spoke with the events team of YC.
Yeah.
We literally took some Google satellite images of where it was going to happen. We cordoned off the area that we need to get the excavator. We planned how will we get the excavator into the arena.
Yeah. That's crazy.
Yeah, and then.
So did you rent it or buy it, or then you go online and say, how can I get an excavator for next week, right?
So we rented a Home Depot excavator from Home Depot Pro, and
they delivered it to the YC.
They delivered to the YC within the time that we could get it, because it's it's in the custo office, and so we have to make sure and I guess that's one of the proof as well. We returned the excavator back without any issues or damages. So
Oh
like,
yeah, it was retrofitted.
and then
You
we removed
returned
the
back.
retrofit. We
They
returned
didn't see
it.
anything.
Yeah.
Yeah,
So
that's
that
good
was.
to know. Yeah, that's
And we got an orange excavator, obviously, because it's
good.
YC, and we got a Kubota U17, which is a smaller one, and people were able to control it. You control it from a different building over the internet.
Yeah. So YC Demo Day is two buildings. The one in the YC, the actual YC building, and then the sort of lunch and drinks area and stuff, and demo area usually on the other side in the Astranis building. And so yeah, it was like I don't know, quarter-mile distance or something. It was far, and it just works. And so then you had almost everyone. I mean, a lot of people came up, tried it.
Yeah.
What did people think? I mean, I thought it was really cool, but what were the overall reactions?
I think people were blown away because of how seamless it was. So like the remote tele-op was actually pretty low latency.
It was low latency. I remember. It's like it's not instant, but it's almost instant. It's
exactly. And the other thing people realized is how hard it is to operate these excavators, which is why you need skilled operators. And we had like some people who noticed the small visual elements where, the windows would go larger or it would like essentially become smaller based on how we are controlling it. We showed the autonomy as well. We actually trained autonomy model from the alumni demo day, from the 6 hours of data that we had from alumni demo day.
Oh, wow.
And then we showed that on the actual demo day as well.
Oh, wow. Okay.
Yeah.
Oh, that's cool.
So that was like a super small model of very specific task of picking up that bucket and placing it onto the table. And we were able to do that with 6 to 7 hours of data.
That's encouraging. Just with 6 hours of data, which is 1 day of work.
Yeah.
You can actually train, obviously very small, but you can train some autonomy. So it's all about the data, actually.
Yeah.
Okay. Let's go. So it's a perfect sort of segue to YC in general. That was my intro. YC is a, B2B AI SaaS.
Mm-hmm.
Well, you're an AI company, obviously, but you're not, B2B SaaS. When did you get the idea of actually going to YC?
Mm-hmm.
Was it sort of obvious for you, hey, and your co-founder, we're building this, we got to, or, were you hesitant of like, oh, it's a hardware company? To start with, at least, it's a hardware company. Should we go to YC or not? Like, what was your thinking around this?
I think YC is YC for hardware and construction both. There's many examples out there. Cruise is one of them, as we were talking about.
Very relevant to you.
Yeah, exactly. Like pretty much similar playbook. And then also like biggest construction companies in US are actually YC companies, which are like in the plain sight, we don't really see it, but like Equipment Share, which is like third biggest equipment rental company in construction, pretty much out there on the ranks of United Rental and Hook. Wow. Is a YC company.
Really?
Yeah.
Oh, I didn't know.
And PlanGrid, which was acquired by Autodesk for about $1 billion, is also a YC company.
Yeah.
So in different areas of construction as well, there's a lot of YC companies which have done it. And we were able to connect with all of them, because YC founders like to help out other YC founders. Yeah. We got so much of takeaways from their journey and because I literally came to US few days before YC started.
Oh, wow. Yeah.
And I was able to learn things much faster because of, having that kind of community of companies who were like very specific to our industry coming from YC as well. And like, that's literally, they're literally the best in their segments. So if I think about it, YC makes sense even if you're not a software company. There's obviously less of those because the biggest problem in those areas is getting the sales and getting the GDM and showing traction, because you're not selling to developers or you're not selling to consumers.
Yeah.
But I think if you can do that, you're if you're making something people want, you could do YC essentially.
So interesting and so inspiring. Getting access to some of the, did you get access to the cruise people, for example?
So I had been talking to Kyle previously as well, actually. Oh, wow. So the interesting story here is before building Flywheel, I was building a remote tele-op dev tool for robotics companies. So it was a dev tool which other robotics companies could use for low latency. Because the idea was always to solve the data flywheel problem in robotics, which is...
That's where the name comes from.
Yes.
Okay.
So that was the initial angle at it. And then it was pretty bad because nobody wants to use third-party dev tools in in robotics, and selling to robotics companies is very small TAM. Like it cannot be $100 billion business. And if you cannot make $100 billion business, you can't solve the data flywheel problem.
Yeah.
And that's essentially like I was talking to a lot of company founders on why they don't choose to use a third-party tool, and Kyle was one of them. Because Kyle had acquired a company because they had really good remote tele-op tool for Cruise.
Wow.
And I asked him, like, would you still buy a company, or would you just, pay X amount per month? And he was like, this is so key that you don't want to expose the controls of your robot that you would still acquire or build it internally rather than use a tool. And so I was like, okay, this is not going to scale.
Yeah, that's a big problem. We should stay away from this.
Exactly.
Okay. Wow.
And there were some other customers using it in interesting ways, which made me realize that high skill, high certified jobs is actually better to do remotely and like with semi-autonomy. And we stack ranked and construction stood out. But like, yeah, Kyle was super helpful in that sense. He's now building his own, humanoid company.
Yeah.
But yeah, we were able to talk to Tracy from PlanGrid as well. And she was quite helpful as well. We spoke with some previous companies which have worked on excavators and like different areas of construction robotics, and they had like really great ideas on and takeaways on the difficulties on these sites in the US, and like working with the operators and the problems they faced with, and that improved the product for us a lot as well. And like there's usually a big operational challenge for other companies which we do not face now, and so like it has reduced our operational costs a lot.
It's so fascinating because I was listening to you, and you arrive in the US, and within 3 months, you spend time with the founder of Cruise, you spend time with the founder of PlanGrid, you spend time with Paul Graham, you spend time with Gary Tan and all of the YC partners, and Ankit, your partner, who's built amazing, they've all built amazing companies. Like there's no other place in the world. People wonder, why are YC companies so good? That's what people don't like. People say you're the average of the 7 people you hang out with or something. Like this is the people you're spending time with, and now you're spending time with me. I'm like, oh my god, I'm lowering the average. But you spend time, with Paul Graham and Carl from Cruise and all of those people, and again, all of those YC partners. Again, everyone takes those partners for granted. They're just YC partners. No, they're not just YC partners. All of them have. I saw a post from Gary, I think it was this morning, where Andrew, the newest YC partner, Andrew Miklas, was interviewing the founder of Vercel. And he said, like, both of those people on stage have built 9-figure businesses.
Exactly.
And they're just spending, giving back, just helping the next generation. It's so crazy. So I for everyone who's out there, I mean, I don't need to advertise YC. Everyone knows YC is great, but just think about this. You come to the US and within 3 months you meet all of those people. It's just so crazy. I want to go to something you said that's, I think, a very interesting topic for many people, because I get asked about it all the time, is, okay, and you touched on it, so I want to expand. It's difficult for a hardware company to make it at YC, to fit into the YC mold, because YC is in 3 months, you're going to go to traction, go to market. And you said, well, most hardware companies, it's difficult for them to actually build something on time, to actually get customers signed. So how did you do it, and how do you do it in general as a YC company to actually build something in 3 months? And you did it, and maybe we could argue that maybe it's easier for you than for someone who's building an entire space, station or something. Like there's people building refueling in space or space stations or whatever. Probably it's slightly harder for them than for you, but still, you built hardware in 3 months. And so how did you do it? How, in general, would you advise companies to do it and to actually sell? So build it, sell it. Let's start there, and then I want to ask you about how investors should think about this as well. But how should a company build hardware and sell hardware in YC in such a short time frame?
It's just funny because when you were like talking about the YC journey, I was getting memories, and it's weird because you feel it was yesterday and you also feel it was like a decade ago.
Already, because you're moving so fast.
Exactly.
It's been a month, right?
Yeah,
That you finished.
yeah, exactly.
But a month in YC is like at least a year
Exactly.
in normal people's life.
Yeah.
That's a beautiful thing about YC, by the way. It's
It
just
is.
accelerating
Yeah.
everything about you.
Exactly.
Which is good. You have more cycles, more
Yeah.
iterations, and everyone should build like this.
Yeah.
Anyway, sorry, keep going.
I think the way I would, so like we actually went from a toy excavator in our apartment in a literal sandbox to like putting it on an actual excavator in the demo day. But what was very important is figuring out the right problems to solve for construction companies. I think having that same vocabulary and like explaining, showing it to them that you have the understanding of the industry and you understand their problem and you're making a solution to solve those problems was key to getting that initial business traction without having something built out. So we actually started building after we got some initial traction.
Just to repeat this, because I've actually never heard this. It's fascinating. Your key insight is get the traction before you build the hardware.
Yeah.
And you do that by proving your real deep understanding
Yeah.
of the problem you're solving.
Yeah.
And if you're proving that you understand it so well,
Yeah.
they're going to give you the contract.
Yeah.
That's so cool.
Because
I love this.
Yeah. And because like hardware iterations are pretty slow.
Yeah.
And so you don't want to make something and then show it to them and hope that that aligns with what they want. Because if that's not what they want and if they are still able to take a bet on you, it would still be because of your understanding and that they like you and they would like want to work with you on solving this problem with you. And so you would have to make that another iteration again anyway. And so you could just delete all of that and just essentially go like into the construction sites, understand the operation challenges, and then go to them and be like, you can solve this with your robotics background and show the all the previous work that you have done.
It makes me think it's almost I mean, I'm sure it's very different. But also,
Yeah.
it's almost like vibe coding. When people say now the people say instead of it used to be you just type in 2 sentences and it gives you something that's not very good, and then you try to refine it and refine it and refine it and refine it, and it never really works. And then people now say what you should actually do with vibe coding is you should try to one-shot it. So you should take more time to prepare. You should really make a longer prompt with all the details, and then try to one-shot it. And so again, it's very different, obviously, but what you're saying is pretty similar in a way. Like instead of rushing to a prototype that's going to be very bad and then iterating on it, but you don't have time in 3 months. That's why everyone is stuck. Everyone keeps asking me, how do you do hardware in YC? Because you can't iterate fast enough. It's not software. Your answer is super interesting. This is going to be the most viewed episode of the channel. I hope. Smash the like button. Give some love. Give some love to the thing. It's you actually don't rush to create your first terrible mock-up, your physical product. You take some time, sort of step back, gather data, really understand what you're building, and so then you would build it at the last minute before demo day, like in the last 2 weeks. How would you split it? You would spend 2 months or 2.5 months gathering data and then build it at the very last minute?
Yeah, I'm a fan of this footballer Messi, and so if you have seen him play soccer or football, he essentially just walks on the field or like is very stationary until he has scanned the ground and he knows what he needs to do when he gets the ball. And until he gets the ball, you look at him and you'll be like, are you sure he knows how to play football?
Are you sure he's a good player?
Yeah.
Yeah, and he's one of the greatest, right? For people who don't know, like he was like I don't know, even not even of his time, but like of the 300 years of football or whatever.
He's the GOAT.
He's one of the best ever.
Yeah.
Sorry, keep going. Yeah.
And once he gets the ball, in 10 seconds it's a goal. He just knows how to navigate. He knows exactly where his players would be, where he needs to pass, and it's done. But like before that, he has done all the groundwork to do that very effortlessly and very like cleanly just score a goal.
Wow.
I think like that's essentially how I would think of this, is especially because with hardware iterations are expensive and slower. And so your whole feedback cycle is pretty slow in terms of figuring out whether this works or not. And so you want to minimize those iterations and you want to make those iterations faster. And we literally just built out the whole thing in the last few weeks of YC, in like, I think last couple of weeks. And a lot of initial iterations within those 2 weeks were 3D printed just to like check out the functionality of it. And then towards the end, we essentially had something which was CNC made.
Wow. So cool.
So
Preparation is everything.
Yeah.
Yeah, don't rush maybe into the thing. Like when you're in software, you can.
You can.
When you're not. Is YC
even in
this?
software, I think like even in software, the experienced software engineers would like try to think of all the edge cases, come up with a PRD, and then, as you said, like, you know, you try to give as detailed prompt to cursor or something, and yeah.
So cool. Yeah, it is counterintuitive. And entrepreneurs are biased towards action.
Yeah.
You want to act, but sometimes the best action is to prepare. It's still an action. Does YC give you that advice as well?
Yeah, I mean, I think it's literally it's hidden in the make something people want.
Oh.
And so I think you first you're still acting, you know, but you're trying to understand, you're validating hypotheses in terms of what the product should be by talking to the customers and like figuring out. You could literally ask them, why don't you use the competitor's product?
Yeah, that's a good
and
question.
you can learn a lot about without ever having to build anything. And so we essentially openly just list out all the competitors to the construction companies, show them their solutions, and ask, okay, why does this not work for you? And then we build out something that they actually want, which saves you a lot of trouble from, you know, it's interesting because you don't get into the herd mindset of trying to build something which others are building because you think they have done the groundwork of doing the market research and talking to the customers.
And they haven't.
Yeah. You just show them all the alternatives and you essentially you're sitting down with them and then seeing what software they're using, what they don't like about it. And then you just build what they find missing or like what essentially turns them off from the existing solutions. And you can do that in a much more optimal manner.
It's so interesting because I'm European and there's this thing in Europe that if you're building something that's already existing, it's not good. I've heard my entire life.
Yeah.
I'm like, oh, I'm investing in this company, they're doing this. And people tell me, it already exists.
Yeah.
And it's so crazy because Google was not the first search engine.
Yeah.
Facebook was not the first social media. And so what I tell people all the time is it's not about being the first.
Yeah.
It's about being the best.
Yeah.
And what you're saying reminds me of that. I think it's the cultural difference here in the US compared to Europe is we don't really care if you're the 20th company doing this as long as you're doing it better.
Yeah.
And you know, Google was their ranking algorithm was just so much better. It was faster and better results.
Exactly.
And they were number 10 or something or 14 or I don't know.
And they try to tell the existing search engines that, you know, it doesn't really work because when you try to search for something, it doesn't show you what you want, and they're like, you should not search it that way.
Yeah.
Which is
terrible.
Crazy.
Yeah, it's crazy. But what you said here is goes one step further. For me, it's the same universe. I love it because it's applicable to almost any company. But again, I've never heard it this way. So, you know, thank you. Is if you want to build in a space, how do you make something new? And it doesn't have to be new, it just has to be better. And how do you make something better? Well, you can go to your customers and be like, hey, those are all my other competitors. You know, you could go to someone in 1998 and open a laptop and say, hey, here are all the search engines.
Yeah.
What's good, what's bad, why don't you use it,
Yeah.
what could be better? And people are actually going to tell you.
Exactly.
So that's where you say it's into the make something people want.
Yeah.
You ask people what they want.
Yeah.
And then you make it.
Exactly.
It's so good. Okay, I love this very, very much. We can clearly see, or I can clearly see, I think the audience as well, that you've thought a lot about this entire thing, this entire process of what you're building and why, but also how you're building it. Very impressive for me to watch across the table here. You also, probably the last piece missing, and I'm sure you have a great answer because everything I've asked you have amazing answers. So I'll just keep extracting the nuggets from you, is you also said you should, preparation is everything. You should take some time, and then you should rush, or then you should build it only when you've prepared enough. You also said you should accelerate the iteration cycle.
Yeah.
And so again, this is a problem for a lot of people in hardware.
Yes.
How do you make that fast? So you gave us an idea of, instead of doing CNC from the beginning, you do 3D printing.
Yeah.
You can do it in overnight,
Yeah.
and you iterate this way very quickly.
Yeah.
I have another company that I've invested in that does exactly this, just 3D prints overnight and test again. Are there other ideas, techniques, or I don't want to say secrets, but whatever you've used to iterate quickly in hardware that you can share with the audience?
Yeah, 100%. I mean, the biggest problem in hardware is the downtime of your engineers, which is literally them being stuck because of lead times. And the parallel I draw to this is this filmmaker Damien Chazelle, and like how he makes movies in like very short amount of time by planning literally everything out and parallelizing things.
Okay.
So that's essentially how he made La La Land and Whiplash very quickly. And you could essentially do a lot of things in parallel which are non-blocking, and you could run them through processes which would have lesser lead times. And so you need to have a really good understanding of all the lead times from like beforehand, and you need to essentially keep on confirming that those lead times are still like the updated lead times, and so you have an updated understanding. And then you want to have that as one of the weights in how you make the decision in terms of what process you should run. And so we got a bunch of printers. We had a whole lookup table of friends who had different printers and CNC machines in the Bay Area and how far away they were from us. So we, at any given point, we had like 5 different options to do the same thing.
Wow.
And we had a great understanding of how long each of them will take. And yeah, I think like if you just make it data driven, and then you try to like stack rank it, you would be able to like reduce the downtime a lot. And
Crazy.
So we always knew that, when this is happening and the engineer can't really do work on this, we can have, in this case, the engineers is literally me and my co-founder, but like we could focus on the other parts of it which are not blocked by the manufacturing or testing out of this particular thing. And so we compartmentalized, we sort of isolated and decoupled everything as much as we could. And we just did a lot of things in parallel. And obviously we were working pretty hard as well.
Yeah.
I think like, I think the people in the building saw us literally like 22 hours a day in some of the days leading up to the demo day. But yeah, I think...
I love this last part of decoupling, parallelizing, etc.
Yeah.
I just love this. Is there any resource, book, blog article, whatever, like where did you learn about this? Where could the audience, and I actually want to, if there's a book about this specifically, I want to learn how to do this. Because it makes, like I can feel it in my business, and I think everyone does. Like you have those bottlenecks, and then everything after that gets stuck. And so if you can parallelize, have different options, you can just unstuck everything.
Yes.
Where did you learn? Where could we learn about that?
I think the first time I started thinking about this was from High Output Management by Andy Grove.
Okay. Oh yeah, I've actually heard about the book several times.
It's a pretty good
Talks
book.
about this.
Yeah, with like
actual today.
With like actual graphs, and he actually does that with very simple example of a breakfast place, which is has to make toast, coffee, and eggs, and so those are 3 different processes with different lead times. And how can you make sure that you serve a customer which orders all 3 of them constantly, and how do you sort of turn that into a factory? And I think like that's a good book to get started. And then obviously we had the experience from our backgrounds and like all the scar tissues of not doing that well, and we just had that understanding of how we should be doing it.
So cool. Okay, on my reading list, top of the pile.
100%.
Thank you so much. That's a good place to leave it. Thank you so much. Where can people reach out, find you? What's the best way to stay connected, to hear about Flywheel, to follow your updates?
I think Twitter is the best place. I'm Jash_Mota.
Jash_Mota. Okay. 2 T's, 1 T?
1
T.
T.
Oh, 1 T.
Yeah.
Okay. Jash_Mota, 1 T.
Yeah.
Very cool. Thank you so much for being here.
Thanks.
Had a blast.
Thanks for having me.
To our listeners, if you're still here, thanks for listening to us until the end. I mean, I'm pretty sure you're still here because it was fascinating. Please consider subscribing to this channel. If you're listening on your favorite podcast app, consider giving us a 5-star review there. It really does help. You can also turn on the notification bell on YouTube to be aware of the next video we publish every Tuesday. I bring you a new amazing YC founder like Jash. Also, please consider checking out my sister channel, where it's solo videos of me talking about the VC world, the YC ecosystem. You can find that channel by typing my name, Gabriel Jarrison, in the YouTube search bar. Thank you so much, and see you next week.